Hello and welcome to the tied-up video demonstrations of basic physics concepts. In this video, we review the concepts scalar and vectors and introduce the elementary concepts of position vector. In a very simple sense, we can say that a scalar quantity has only magnitude. If a quantity can be described completely by a single numerical number, then it is a scalar quantity. For example, if the distance you traveled from home to school is 2 miles, then the quantity distance is a scalar. Because this quantity is completely described by a single numeral, 2, along with an appropriate unit. Similarly, your time of travel from one location to another location is a scalar quantity. This quantity also needs only one numeral for its complete description. In similar fashion, temperature of your coffee, volume of your soda, weight of your body, etc., are quantities that can be described by a single numeral, and with an appropriate unit. However, not all quantities we observe around us can be just represented with a single numeral and a unit, as we see, in case for scalar quantities. For example, if you want to express the location of your car, parked in a parking ground, by only one number, say 3 meters from building A, that won't be enough. Because there are several locations near building A at the same distance. If you say, it is 3 meters south from building A and 8 meters west from building B, then you probably able to locate the exact location of your car. That means, there are some quantities that require more than just one single numeral for their accurate representation. A numeral, with a direction, or a number of numerals, with directions, can be used for representing such quantities. We call such quantities as vectors. Therefore, we can say that the position of an object is a vector quantity. Another example of a vector quantity is force. If someone needs to push an object up, he needs to push or apply force of certain numeral value and with a proper direction. In this case, we say that the quantity force is a vector. In summary, we can say that vectors are physical quantities that require both magnitude and direction for its complete representation. Now, let us consider again the example of location of car discussed earlier. We have seen that the location of this car can be accurately represented by 2 numerals and 2 directions, and we realize that this is a vector quantity. More accurately, we can say that we have used 2 references when we mentioned about the directions. That is, north of building A, and west of building B. Choosing more specific and mathematically useful references will allow easier representation of such vector quantities. For example, using a Cartesian coordinate system we can represent the position of car in more systematic way. In this representation, instead of using directions north, south, northeast, etc., we can use directions I, j, I, j, etc. In this case we can say that car is located 8 meters from the y-axis, in the positive, I direction, and 3 meters from the x-axis, in the positive j direction. The resulting position vector can be represented as vector OA. Vector OA is 8I plus 3j. The simple meaning of this representation is that the position of the car can be identified by moving 8 units in the positive I direction from the origin and then 3 units in the positive j direction. We will discuss more about the concept position vector in the next video. Thank you for listening.